Hello everyone. In this video we will discuss about the concept of cis and trans isomers. This will be a small video. So let's do a quick recap. So if you remember, what is the name of this compound? So this compound was, we got 4 carbon atoms. So this is but because it is 4 carbon atom. Then it has one double bond, so one double bond, so if it's one double bond, then it's in, so the name is butene. And how did we name them? So we gotta number them, and you have to assign the least possible number. So in this case, 1 2 3 4. So this is a 2-butene. All right, so let me draw another butene right beside it. So then you will try to differentiate. Okay, so this one also has 4 carbon atom, 1 2 3 4. So 1 2 3 4. So this one is also have 1 2 3 4 carbon atoms. So this is also butene. And what is the location of the double bond? The double bond starts at the 2. It's always, this is where students get confused. Some people write as 3-butene, which is not correct. So you want to look at the carbon atom where the double bond is starting from. So the starting location is 2. So that's 2-butene. Okay, so both are 2-butene. However, those 2-butenes are not the same. So here's what I meant. Can you see the difference? Find the difference. Find at least one difference. So you can notice the CH3 group. I'm circling the CH3 group here and the CH3 group here are on the same side of the double bond, right? So they are both on the top side of the double bond. So these are called same side. But if you look at the here, you notice the CH3 here to the bottom, CH3 here to the top. So these two are opposite side. So the same thing for hydrogen. So the hydrogens are here, are same side, and here the hydrogen are on the opposite side. So if one is on the opposite side, then obviously the other one has to be on the opposite side as well. Okay, so same side and opposite side. So these are two different compound. So if it is on the same side, we call that as cis. If it is on the opposite side, we call that as trans. So we have to assign that cis and trans to our name as well. So when you are given a structure, and structure is asking specific question, what kind of isomers? So obviously both of them are isomers of each other. So that's called cis and trans isomers of each other. So these are called geometric or stereoisomers. That's a little bit advanced. So just know that these are cis and trans isomers. So we have to assign cis to butene, and this one would be trans to butenes. All right. Okay, so again, so all you have to do is figure out whether the bulky groups are on the same side or opposite sides. All right, so let's do another quick example. Let's see if you could figure out whether they're cis or trans. Good. uh, so let's say C double bond C H CH2 CH3 H CH2 CH3. Okay, let's figure out what is the name is going to be. Okay, obviously it has 1 2 3 4 5 6 carbon atoms. 6 carbon atom means hex, and it has at least one double bond, so it's gonna be hexene. Where is the location of the double bond? It doesn't really matter because 1 2 3 if I count from the left to right, it's coming at 3. If I count from right to left, it's coming at 1, 2, 3. So it doesn't really matter. So let's do left to right, right? 4, 5, 6. Okay, so this one would be 3-hexene. So what kind of isomer this one would be? Because the two bulky groups are on the same side of the double bond, and the smaller group, which is the hydrogen, are on the same side as well. So it's gonna be cis 3-hexene. All right. Okay, so let's do another quick one. So always remember, the carbon should always have 4 bonds around it. Okay, so let's try to find the name of this one and figure out whether it's cis or trans. So this one, how many carbon atom we got? 1, 2, 3, 4, 5. So that's 5 carbon atom. 5 carbon atom means it's gonna be pent, and it has at least one double bond, so it's gonna be pentene, the shampoo. I'm just kidding. I don't think it's just the name. Okay, so pentene. Where is the location of the double bond? Okay, this one you have to be very careful. If I count from left to right, 1, 2, 3, 4, 5, it's coming on the location 2. If I would have count from the right to left, 1, 2, 3, it's coming on location 3. So obviously you're gonna pick left to right, which is the smallest. 1, 2, 3, 4, 5. Okay, so this becomes 2 pentene. Okay, last thing we gotta figure out, uh, are they on the same side or opposite side? So if you look at here, on this particular carbon atom, the hydrogen is small. So this one is small, this one is large. Maybe I color code something different. So this one is large. Obviously, if you have one hydrogen, it's gonna be a smaller group, right? If you have a carbon and 3 hydrogen, it's gonna occupy more space in the 3-dimensional space, right? So on here, the CH2 CH3 is the large one, and hydrogen is the small one. So if you notice here, the large groups are on the opposite sides and the small groups are also on the opposite sides. So that's gonna be when they're in the opposite, then we're gonna call them trans. Yep, that's it. That's all I had to say. So if I ask you, can you draw the structure of, let's say, trans 2-hexene? How would you do it? Okay, let's figure out. So you start with the parent name. Parent name is hexene. So let's draw a skeleton. So 3, 4, 5, 6. So where is the location of, so it is an ene, so there is a double bond. And where is the double bond? At the location 2. So 1, 1, 2. So this is where the double bond is going to be. So we figure that out. Okay, so next thing is add hydrogen. So make sure everybody has 4. So H, 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 H. Okay, so just make sure everybody has 4, otherwise you're gonna do mistakes. Okay, so next thing is we have to figure out trans. So let's write this down in a condensed formula, CH3, C. So this is where the double bond is happening. So let's make it a little bit prettier. Okay, so this is 1, this is 2, next one is here. Okay, so now you have 2 choices. You have to put hydrogen somewhere, here or here. So if you look at what is it? it has to be opposite. Trans is opposite. So the hydrogen was here, so it should be opposite. So this hydrogen has to be opposite. And also the CH3 is bigger group, so the other bigger group is the remaining carbon chain, right? So other remaining group has to be on the opposite as well. So this one has to be opposite. So in this case, it's gonna be, what's the next in line? 2, 3. So this is 1, 2, 3. So this one would be the fourth. Fourth one is here. Fourth one, fifth one, sixth one. So the fourth one is CH2. So let's write that down, CH2. This one here is gonna be CH2, fifth one. Sixth one is CH3. Yeah. So either you can draw like this, or you can extend if you want. You can extend here like CH3, CH2, CH2, CH3. Okay, so that's all about cis and trans. Focus here. Cis means same side, trans means opposite sides. All right, that's all I had to say here.